Hi, welcome to my YouTube channel. In this tutorial, we are going to start Ansys heat transfer. So, in this tutorial, we will understand the Fourier's law, and how it is applied by the Ansys solver for modeling the conduction. So, in regarding that model, it will be a simple cubic block with the applied temperature at each end, and the results obtained with an ANSYS will be compared with the hand calculation. So here we are going to double click on model. So the mechanical window has been opened, and first what we are going to do, first we will go to home, and there just click on units, and here we are going to change this to metric. Now we can see the model. If we click on the this edge, we can get the length, that is 5 meter. And also, if we want to get to know about the cross section area, if we click on this edge, we can get length 1 meter by this is also 1 meter. So cross section is 1 by 1 meter and length is 5 meter. Now click on mesh and generate mesh. So mesh has been generated here. Now we are going to insert temperature at this end, apply, that is we are going to add here temperature 20 degree centigrade, and insert another temperature that will be on the other surface, apply, and it will be 120 degree centigrade. Okay, so click on the two and drag on solution, so this we can get reaction probe at each cross section. Now we are going to solve. So this model has been solved, and also we are going to insert thermal temperature, evaluate all results. Okay, so we can see temperature whatever we have applied, 20, that is minimum at this phase, 120 at the other phase. Reaction probe at this phase, so that heat is minus 1210 watt, and at the other it is 1210, so that is positive, means the heat is flowing from this cross section to this cross section over this length of 5 meter. Here now we have, if like this is a uh, simple analysis, so here we can do hand calculations also. So what we will do here, we have input data of like area it is given 1 meter square, length is given 5 meter, and the thermal conductivity of the material it is given 60.5 watt meter. So this has been given, and also we know the Fourier's equation, that is delta T upon thermal resistance. Okay, so here this resistance we can get y L upon K. So by putting all the data, this resistance will be 0.082645, and put this value in this equation. Temperature difference, that is 120 minus 20 upon 2645. So this value will be, after solving it, will be 1210 watt. So that what we have got here, you can see. So here also we can go to, if we go to this project window and engineering data, structural steel, so you can also see thermal conductivity, it is given 60.5. Okay, now what we are going to do here, we are going to suppress temperature 2 and reaction probe also suppress, and we are going to insert heat flow at this phase, apply, that will be 1210 watt. Now we are going to solve. So this has been solved. If you see temperature here, it was 20, and from there we have removed that 120 degree, and only we have applied that heat flow, so that it is showing 20 the minimum that is here and 120 the maximum at this phase. Reaction probe is same 1210. So this was all about a simple analysis of conduction. Thank you for watching my video. Please like and subscribe.